This video is a recording of today's lesson. We're going to start with a warm-up. So please pause the video for a moment while you try this problem. We need to make sure that you remember how to do these straightforward acceleration calculations. Alright, now that you've had a chance to have a go at this one, remember that when you're doing these kinds of problems, it's important to read it carefully, identify the data, make sure you understand what units of measurement are being used, and apply the correct formula. So here we're finding acceleration, and we can use A equals V take U over T. Step one is always to write the formula, then we substitute the data into the formula, and then it's time to reach for your calculator. So 10 take 2 equals 8 divided by 2.5 will give you an answer of 3.2. And don't forget the units. We're finding acceleration. The numbers have been in meters per second and seconds, so the acceleration will be in meters per second squared. Now, just one tip to make sure you don't make a mistake with your calculator. Since we're working with fractions, it's a good idea to put brackets around the top line because I'm finding the difference of two numbers, and that way you will be guaranteed to get the correct answer on your calculator. Alright, so for the rest of this tutorial, we're going to look at a few different examples that use different forms of that basic formula. So once again, please pause the video now, copy out the example, and then you're ready to proceed. So in this question we're actually going to find the initial or starting velocity of an object. And by the way, I apologize for my writing, which is a bit rough today. So as always, read the question carefully, and it's actually not a bad idea to list the data down the left-hand side as you go along. So first of all, the final velocity we are told is 16 meters per second. The symbol for final velocity is V. The acceleration is 1.5 meters per second squared. Symbol we use is A. And the time is 8 seconds. And we are going to find U, so I've listed that as U equals question mark because at this point it is an unknown. Now, the formula can be rearranged to this: U equals V minus AT. You need to do a bit of algebra to rearrange formulas, which is beyond what you need to know for this course. So in a test you will be given that form of the equation if you need it. But as always, make sure you start by writing the formula down before you substitute the data. So we have 16 minus 1.5 times 8, which gives us 4. And the units, noting once more that our data has been in meters per second squared, and seconds. They're all standard units, so we should have a velocity in meters per second. Example 2, once again a slightly different version. Please pause the video and write it down before proceeding. Now in this question we're not actually told that the stone is starting from rest, but I think we can assume it is. So the time for the fall is 6 seconds, t equals 6 seconds. And the acceleration is the acceleration due to gravity, which is a constant 9.8 meters per second squared. We've seen a video of a feather and a bowling ball falling down towards the earth at exactly the same rate. So acceleration due to gravity, 9.8 meters per second squared. The initial velocity, as I said, I think we can assume is 0. And now we're trying to find the impact velocity, which will be the final velocity, V equals U plus AT. But we can write that as V equals U plus GT because we know that the acceleration is 9.8 due to gravity. Now we substitute the data. U equals 0 plus 9.8 times 6 and we get an answer of 58.8 meters per second. So this problem is a little bit different than what we've had before, because we have an object in free fall accelerating towards the ground at 9.8 meters per second per second. Now, I'm interested to know what that is in kilometers per hour, so just pause the video one more time and work it out for yourself. Hopefully you remember how to convert between meters per second and kilometers per hour. Okay, so if you've forgotten meters per second to kilometers per hour, you can just multiply by 3.6, and to go the other way, kilometers per hour to meters per second, you would divide. So in this case, we are going to multiply by 3.6, which gives us a velocity of 212 kilometers per hour. It's a good idea to put that conversion onto a summary sheet and make sure that you are ready for the test that will come soon enough. Okay, example 3. One more time, please pause the video and copy this out into your notes. So once again, a slightly different version where we're trying to find the time. As always, read the question carefully, identify the data. So let's start with A equals 4.2 meters per second squared. That's our acceleration. We're also told that it starts from a stationary start, so U equals 0, and it reaches its final speed of 63 meters per second, which is actually very fast. And we're trying to find time, so T equals question mark. Now once you've listed the data, if you've used those standard symbols A, U, V and T, then you will very easily recognize that we are going to use the basic formula for acceleration, A equals V take U over T, or V equals U plus AT, or a slight variation on that. So here I can tell you that time will be V take U over A, and substituting the data will lead to an answer of 15, and once again they're all standard units, so it will be 15 seconds for this train to accelerate from rest to an amazing speed of 63 meters per second. Okay, so those are the examples for today. You can review this video at any time. If you haven't written down all of the examples completely, please do so. And your job for the rest of today's session is to go on and try and complete the acceleration calculations worksheet that was issued a couple of lessons ago. Have fun.